Welcome to Envisage, an expressive visual graph querying system that helps users easily construct, verify, and execute complex graph queries. Envisage guides users through 4 stages: query expression, query verification, progressive query execution, and result analysis. Users begin by visually constructing the query graph using basic elements or predefined motifs such as loops, paths, trees, and clicks. They can also select some entities as customized entities. Envisage supports a powerful rule-based configuration. Users can define attribute filters, repeat or chain substructures, and express structural ambiguity. A rule list shows all user-defined rules for each entity. Users can easily review, modify, and remove these rules with the rule list. To verify query correctness, Envisage generates all possible instances based on the rules. Users can explore how each rule combination expands the query structure. If mismatches occur, users can inspect the rule list, preview each instance, and revise their queries accordingly. Queries are executed progressively. Envisage allows step-by-step execution to help identify which rules lead to failure or unexpected results. Result frequencies are shown in context of the entire dataset. Each matched subgraph can be reviewed in detail, enabling users to examine properties, explore patterns, and refine insights. Next, we present several scenarios to demonstrate the usage of Envisage. This dataset represents a money laundering transaction network. The nodes are accounts, and the edges represent transactions between them. The user wants to analyze whether the dataset contains specific money laundering patterns. First, the user wants to know whether the criminals disperse illicit funds across multiple accounts, then consolidate them into a single account, and finally disperse them again. With Envisage, the user easily expresses this complex query by connecting 4 nodes and applying to repeating rules to Node 1 and Node 3. Since the user does not know the exact number of accounts receiving the funds, he sets a range for each repeating rule to express the ambiguity. In the query instantiation visualization, he confirms that the generated query instances match his expectations. Then, he wants to constrain the values of all transactions in this query to be greater than 0. Instead of adding constraints to each edge individually, the user selects all entities as a customized entity and applies a single edge attribute rule to constrain all edges at once. Finally, the user progressively executes the query instances and finds that one of the rules causes half of the instances to return no results. With Envisage, users can efficiently express complex graph queries by combining a variety of intuitive rules, reducing the effort typically required. In summary, Envisage empowers expressive visual graph querying by enabling users to articulate and diverse query intents in a flexible and user-friendly manner. For more information, we warmly invite you to explore our paper.